I'm not sure there's a lot less code being written in C. The less specified a language is, the more room there is to optimize it. There's this desire to want it all, but when push comes to shove, performance has been winning out over security in terms of the decisions that are being made. There's a lot of reasons to try to code securely to begin with. Fixing defects later in the development cycle, it's more likely that you'll fix it incorrectly or introduce additional defects while you're repairing an existing problem.
Hi, I'm Guy Pojarny, CEO and co-founder of Sneak, and you're listening to The Secure Developer, a podcast about security for developers, covering security tools and practices you can and should adopt into your development workflow. It is a part of the Secure Developer community. Check out thesecuredeveloper.com for great talks and content about developer security and to ask questions and share your knowledge. The Secure Developer is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com. Hello, everybody. Welcome back to The Secure Developer. Thanks for joining in for another episode. Today, we have a great security trainer with us, Robert Seacord. Welcome to the show, Robert.
Thanks for having me.
So, Robert, before we dig in, we're going to go a little bit more sort of bare metal here, or maybe like a little bit more sort of C++ programming security and the likes later in the show. Can you give us a little bit of context about yourself? You know, who you are, how you got into security, what do you do these days?
Sure. These days, I'm a technical director at NCC Group and sort of split my time between doing secure coding training, developing secure coding training, research, and customer work, doing a lot of security code analysis for various customers, reviewing source code and the like. How I got into security, I started as a developer for IBM back in '84, and I had a startup company in '91. I worked for a company called Secureware down in Atlanta, Georgia, and did not do any security work for them whatsoever. Continued on my career, went back to the SEI in 1996. And then in 2003, I just sort of changed tracks completely and went from working in component-based software engineering, and I moved over into the CERT team, originally on the vol handling team. And you can find, I guess, one or two vols that I actually handled. Then I didn't get a lot of direction while I was there, so I wandered off and started writing some books. So I wound up writing secure coding in C and C++, and really liked the security field because it gave me the opportunity to get very lost in the weeds of things and not just have to deliver functionality on a schedule and sort of move on to the next project. So
yeah, more about security as quality. Would you identify first and foremost as a developer or more as a security person?
I'm kind of these days right at the intersection of those two things. So that's kind of my sweet spot because, as a security person, I'm not the best. And, as far as people who are experts at C language, I'm not the best. I mean, most rooms I walk into, I am. But, when you walk into the C standards meeting, I'm the dumb guy.
The joy of being broad in your sort of specialties, you have to internalize a lot of things. You can't just sort of focus in on one thing. Let's dig into kind of the meat of your sort of training curriculum these days. You've written a lot and spoken a lot about sort of secure C coding and the likes. At the risk of like condensing a world of knowledge into a few highlights, what would you say are the primary emphases that you give, at development in today when you come in and try to give them like the core principles of secure development, and maybe like how much, if at all, do you feel like that has changed over time?
Well, I think that the devil tends to be in the details, so rather than sort of superficially perform a treatment of a variety of topics, I tend to dive deep, so, most notably the second day of my secure coding and C and C++ training, I tend to talk about integers. And so, 6 hours seems like a long time to talk about integers, but turns out they're, very misunderstood. And, the reality of C programming and C++ programming is, buffer overflows are sort of the biggest issue, both writing outside the bounds of objects and reading outside the bounds of objects. And the way you do that is you add, a pointer to an integer and then start, dereferencing memory at that address. And if you don't know what value is stored in that integer, you really don't know what that eventual pointer is referencing. So you can't have any assurance or confidence that that's not an out-of-bounds read or write.
And how, I guess, like the statement, I guess, would have been true 20 years ago, 30 years ago as well, right? Like this is the mistake for it. Do you see, like, the systems have slightly changed, right? Like, if nothing else, like a lot of systems that used to be written in C++ are now written in other languages, right? Like, like might be written in Java or C# or sort of higher level languages where they don't deal with those pointers.
Yeah.
Do you feel that, or am I just being a little bit, biased, I guess, and everybody lives in their world?
I'm not sure there's a lot less code being written in C. There was kind of a point at which Java was being explored for the desktop, and eventually I think it was sort of abandoned as having adequate performance for desktop applications. Now it feels like it's largely relegated to running server side software. And plus, there's just a world of embedded software. Cars, all sorts of transportation are all written in C.
Yeah.
I've kind of followed the TIOB index over the years, which kind of talks about language popularity. And it used to be Java, C, and C++ are all there with 20+% of the market. But what's happened is that usage has balkanized. So there's more and more different languages, each with sort of less percentage of the market. But at the top is still Java and C. And C++ has actually dropped off a bit. It's now, last time I looked, I think in the 4th position.
Yeah, I think there's actually some reason to that, right? Because from a programming perspective, it might be that C++ was a path towards more sort of structure, maybe a little bit less sort of low-level control, but basically that is now some of that is being taken up by indeed other languages, right?
Yeah, I kind of agree with that. I think to a certain extent, some C++ people went to Java, the people who wanted the abstractions, and the people who were keen on performance and small footprint, all that stuff moved more to C and sort of vacated the C++ space a bit.
So it's an interesting observation, right? And sort of important indeed to remember, I guess, that like the volume of developers as a whole also has increased, right? So like C++ is, C developers are probably continuing to grow as well, and indeed in all those brave new embedded worlds. How much are you feeling, and in the context of security, maybe dealing with agile development? Like, do you feel like in those contexts, is the world of C development a little bit less sort of agile or sort of driven for these bi-weekly shipments, or is it getting the same type of pressures?
Yeah, I don't see C being driven so much by agile development as maybe, sort of website development and projects like that. Agile projects I've been involved with tend to have a lot of problems with security. I mean, it doesn't typically seem to fit into the model of quick release cycles. There's always this sort of short-term push to push functionality out to deploy. And secure coding, a lot of times, is the antithesis of that. It's to focus on, gaining assurance in the code and the functionality you're about to deploy. And some people I've seen even have trouble sort of expressing security in terms of a backlog that they can even address as part of their, release cycle. So there's probably things people are doing to make it more appropriate for security, but to a certain extent, I feel it's not really built into the model. But then again, who knows? I think when you go out and you look at real companies and what they're doing in terms of security processes, it's just always alarmingly much worse than you can imagine, right? I mean, you'll see companies who don't have configuration management in place. I mean, real basic things like that.
Yeah, no, understood. So I think we're basically, it's just these different worlds, right? Like in a website development environment, you might be sort of pushed for faster sort of iteration. Languages might be higher level, maybe a bit more agile. I think we're sort of discussing a slightly different world, which is like you mentioned, embedded systems. Life is connected cars. Quality and assurance is much more important. You can't iterate quite as much. You can't ship a new car every 2 weeks like you need to. And even the update mechanisms are a little bit more controlled there. But also they're written in languages where more damage can be caused, so you have maybe a slightly higher responsibility to invest in that assurance, I guess, for everyone.
Yeah, I mean, when I was at CERT, we kept track of vulnerabilities, but we didn't deal with all of them. So we focused on the more critical ones that, would affect things like critical infrastructure. And as a result of that, 2/3 of the vulnerabilities we found in the CERT database were related to C and C++ code. And again, that's because we focused on critical infrastructure. We didn't focus on, mom and pop websites, in which case, it would have been all PHP and, cross-site scripting vulnerabilities.
Yeah, I mean, it makes sense. Again, kind of just sort of different super high gravity type surroundings, maybe ones where that sort of balance between agility and safety can be taken a little bit differently.
Yep.
So, you do a lot of this assessment now and reviewing. Maybe sort of share some bits of what works well for you. So, like, what's if I can start by what are your favorite reviewing tools when you do sort of analysis of a C code base?
Yeah, I guess the most surprising thing to me is people tend not to use the tools in front of them. I would say starting with the compiler. So we'll talk to organizations that are talking about buying Coverity or buying Fortify or some other high-end analysis tool, but they haven't set their warning level on their compiler, or they're disabling warnings, so they're not seeing sort of critical problems. My favorite warning is the signed to unsigned conversion warning that developers like to turn off, and it turns out that that's a really bad idea, and many of those warnings are identifying real problems and potential vulnerabilities in the code. So I would say just start by using your compilers better. And Clang and GCC now have a bunch of dynamic analysis tools integrated with the compilers. So there's address sanitizer and mem sanitizer and UB sanitizer, and one for thread sanitizer for analyzing parallel execution. And all those tools, along with the static analysis capabilities of the compilers, is very effective.
And how do you know when to be happy with your results? You come across, you look at these are like complicated beasts, right? And you run the review. How do you feel like you've explored the unknown sufficiently to feel like it's ready to go?
Yeah. It's almost about defect detection rates, right? So, how many defects are you finding per, day or per hour of analysis, right? So once that rate declines to a certain point, you get sort of past the point of, where you're getting a good return from that. And usually at that point, it's a good idea to change strategies, because a lot of times once you go to a different tool, a different approach, suddenly you start to find new classes of defects that you weren't finding with the old approach. And so, typically you do what you can until you run out of time.
Yeah, until reality hits you.
Yeah. But usually an indicator that you're getting there is sort of when you're not finding things as quickly, when you get to a diminishing, return point.
I assume like in some of these systems, you have some form of continuous build, right? Like you have some form of automated builds that happen. How do you like to sort of set standards, right? To sort of know you haven't slipped, almost the regression test aspect of security. Do you feel like there are good tools around that? Does it come back again to the compiler warnings and disallowing them?
For regression tests?
Basically to know, like you've set down, somebody hired, the top talent, right, of Robert Seacord. You've gone through, you've done an analysis to sort of help them get to a point that is of a higher comfort. Now they don't want to slip, right? They don't want to regress. So I guess regression tests in terms of security quality, do you set some lines and thresholds?
Right. For example, NCC Group would do a security analysis of a system, including analyzing the source code, and we'll write a report, and we'll identify the defects, and we'll explain what the problem is, what possible mitigations are, and so forth, and that gets moved around, right? But a lot of times it makes sense to follow that up with some on-site training, right, where we'll come in and talk to the developers and give them the training course, and maybe supplement that with some examples from their own system, actual mistakes that they made, and try to up their game on a whole, right? Because I think what you don't want to do is always rely on the pen testers to find the problems in the code, right? I mean, because it's not necessarily the best approach. You really want to not code the errors to begin with, right? Because that's the most effective time to code correctly and securely, is while you're writing the code. Anytime you come back to something, a lot of times you're looking at someone else's code, so you have to relearn that. You have to learn that person's code. sometimes you're looking at your own code, but often you have to relearn your own code because enough time has passed that you're not really familiar with it. So fixing defects later in the development cycle, it's more likely that you'll fix it incorrectly or introduce additional defects while you're repairing an existing problem. So again, there's a lot of reasons to try to code securely to begin with.
I'm going to switch a little bit gears here and maybe talk about people. Indeed, talk about these dev teams from a team composition. We talk tech. Let's talk a little bit about the teams that you teach, right? So, like when you're coming in to do more of a training, or when you interact even with teams to sort of share the results, do you feel like there's any change, like over the last while, right? You've been doing this for a good many years. Do you feel like approaches are different? Like, is there a higher awareness or appreciation for security? Is it about the same? Do you get pushback around, like, it's not my job from dev teams? How do you see the state of the industry amongst the sort of the customer base you work with?
Yeah, well, I would say that there are some changes. We don't really get the same type of arguments that we got into years ago where, we'd call a vendor and say, you have a vulnerability in your code, and they would say, prove it. Nowadays they're more willing to accept that on face value.
Mm-hmm.
So from a teaching perspective, I mentioned this in the intro, but I started out as a developer. And so I've always maintained a developer focus. So, I've had security people come and try to train me unsuccessfully because they would say really stupid things that were just unpractical, things that we would never do, could never do. And a lot of security people tend to be very dogmatic in their approach without having any kind of firm basis for it. And so, when I do teach, I'll tell students that, security is a quality that you have to achieve. And people sometimes ask me, why do people pick C as a programming language, right? And, one of my answers is that, typically security might be fourth or fifth on your list of reasons you pick a language, right? So the first reason would be, hey, we've got existing software it's already developed for this platform and it's in C or it's in C++ or what have you. And, there's an advantage to keeping your code base in the same language. I've had conversations recently about sort of Frankenstein systems, right, where they started in C and then someone switched to Java and then C# and then Rust and then Go. And then you have 12 or 15 or 20 different languages. And those systems become very brittle and very difficult to maintain. So that's the first reason. The second reason might be that that's where your expertise is, right? So if you have a group of expert C developers and you tell them to build the next system in Java, I can guarantee that system will be less secure than the system those developers would have built in the C language.
Yeah.
And then you get to, things like performance and, eventually security might be fourth or fifth, on the list of reasons you would pick a given language.
And I think you're right. And I think fundamentally the choice of language is attuned to what you're trying to do. Like if you built an embedded system in Java, maybe there are some explicit cases where that may make sense, but more often than not, that's just not as performant or it's too resource consumption heavy to fly. And security has to cope. Like you have to build it secure despite the choice of language, whether that's a helpful or negative thing for you.
Yeah, I mean, and a lot of security advice tends to be, again, overly dogmatic, and just saying something as simple as always check, bounds is sort of overly prescriptive because you can look at many loops in C and C++ code and just prove that they don't have out of bounds read or write. So, why waste cycles securing something where there's no possibility of a defect or error when you can use those cycles elsewhere to provide real security?
Yeah.
And, performance and security always tends to be a trade-off to some extent.
So I think we're describing kind of an interesting profile here, which is a little bit different than a bunch of the maybe example systems that we oftentimes have on the show, right? We're talking about these maybe embedded systems, sort of low-level systems, performances of material of sort of a very high importance, maybe oftentimes a physical thing that gets shipped or something that doesn't get delivered or sort of deployed quite as often. And therefore, between the sensitivity and maybe just the form factor, they end up doing security in a slightly more, maybe thorough fashion. How do you feel the engagement? I mean, you come in, people contract NCC Group, or they work with you. Do you feel like before they would bring you in at the end of the process, now they bring you in more midway? Like, has there been a change around when that type of security process is done? I mean, I understand that the deployment, that it's less agile, but do you find is it still waterfally? Do you come in after 6 months of code have been written, or is it more collaborative?
Yeah, it's a bit hard to say. So we certainly get engaged at all points in the life cycle, right? And a good time I think to engage us is to engage us early with the training. And a lot of times during the beginning of a project, you have, a small group of architects and designers who are coming up with the initial architect and design. And you have a lot of developers who aren't fully engaged at that point in the process because they're more novice programmers and not fully engaged in the design process. And so that's a good time to, deliver some secure coding training, get those folks up to speed when they're not necessarily fully engaged yet in the development process. We do get asked to do, architecture design reviews. Those are always worthwhile endeavors, but there are still a lot of companies that bring us in for pen testing, expect the pen testing to go great, are, shocked and dismayed by the results of the pen test, and then decide, to bring us in. I would say even more commonly is just sort of some big exploit gets discovered or published, and then the alarm bells go off, and organizations decide we've got to more proactively address security.
Yeah, I mean, I think that's true at all levels. All levels of seniority and all levels of the stack.
Right.
It's security is invisible, and so when something big happens, to sort of act as this big hit in that feedback loop, it mobilizes people to action. So I think this was, I think, a really interesting conversation, because I feel on one hand the reality you're describing and kind of a lot of these principles are the same as they would be in any language. Like this notion of like people that at the earlier stage of their career, they need more of the secure training and education element of it, while people that are further along, might be a bit more like looking for you for subsequent verification, right? But not quite as they go. Even a lot of the commentary about teaching in the specific examples change, right? Whether it's out of bounds versus cross-site scripting, or sort of knowing sanitize inputs and outputs. Fundamentally, the idea of teaching a principle versus teaching a specific, I think, kind of holds as well and runs with it. Maybe the biggest change, I think, that runs over here is the trade-offs, and the specifics, as well as the pace, maybe, that this world works, like this risk tolerance around the likelihood of a problem, and maybe the tolerance for slightly slower paces.
Yeah, when I think about the training, because I've been delivering secure coding and C and C++ training since probably 2005, so some time now, and the problems don't change very much, right? They sort of remain there in the languages, and particularly C, there's a very strong reluctance to change the language, right? The kind of the first rule in the standards committee is don't break existing code. They're okay breaking compiler implementations, but they don't want to break existing source code that's out there, because the saying is, the world runs on C and we don't want to break the world. And you'll find that there are code bases out there where there really aren't maintainers left for that code, right? So they'll update a compiler and rebuild it with the latest version of the compiler, and if something goes wrong, they're kind of out of luck now. They don't know how to repair that code anymore. So I think the thing that probably changes the most are the solutions, right? So there's different and better tooling that comes along, different and better processes, and sometimes there are newer libraries which are introduced, which are potentially more usable and more secure.
Yeah, I think that's a good thing to hear, right? I think the ecosystem, the surrounding evolves, while indeed, I guess, the sort of a cornerstone of software development that is C remains, a little bit unchanged, for, I guess you can say, for historical reasons, but also because it's pretty darn powerful. It's not it allows you to do a lot of things, including shoot yourself in the foot. It lets you do a lot of good things as well.
Yeah, and the time I've been involved in C standardization, I would say that it's really still driven by performance more than security. And so, we have these undefined behaviors in the language, which the less specified a language is, the more room there is to optimize it. And so the simple view of that is, if you have to go from point A to point C, but you have to stop at point B on the way, and you try to optimize your route, that constraint of stopping at point B is going to limit your optimizations, your ability to optimize the route. But if you can eliminate sort of the necessity to stop at point B, you can come up with much faster routes to your final destination. And so, one of the things that's been going on in the evolution of C is that compiler writers are sort of taking advantage of these undefined behaviors to do sort of greater and greater optimizations. And there's kind of weird pushback on by the C community, right? So the C community will physically show up at standards meetings, representatives, and they'll say, well, we've had it up to here with these optimizations. We've written this code. This code's always worked. You know what it means. You've always known what this code meant, but now you're doing these optimizations and our code is broken now, and, cut it out. And so the compiler writers will say, well, okay, so you can do without these optimizations. And then the C developers will say, well, no, we want those optimizations. And then the compiler writers will sort of throw their arms up in potentially mock disbelief. But, so there's this desire to want it all. And it's not necessarily feasible. But when push comes to shove, performance has been sort of winning out over security in terms of the decisions that are being made.
Yeah, it's an aspect of the functionality, right? You can be secure all the way to bankruptcy. I mean, at the end of the day, the business value is what dominates and security is invisible, right? It's something that you have to work to make visible. So Robert, thanks for sort of the good guidance here and sort of all this sharing your experiences as we went through the show. Before I let you go, I like to ask every guest on the show, if there's one sort of tip, right, or one bit of advice when you have, a team of C developers, looking to level up their security knowledge, what's kind of the one small piece of advice or sort of just pet peeve, a thing you get annoyed, with sort of people repeatedly getting wrong, that you'd give that team to get better at security?
I suspect that every time I get asked this question, I give a different answer based on what's most on my mind at the time. But this time, I think I'll say, take a look write some C code, imagine what sort of assembly code is going to be generated, then take a look to see what assembly code actually gets generated. And then when your expectation doesn't match the reality, read the standard again and repeat until you can predict what the code you're writing actually does. Because people are increasingly surprised by the semantics of the language and what the compilers are doing these days.
Cool. Yeah, that's good advice. Well, once again, thanks for coming on the show, Robert.
Well, thanks again for having me.
And thanks to everybody for tuning in. And I hope you join us for the next one. That's all we have time for today. If you'd like to come on as a guest on this show or get involved in this community, find us at thesecuredeveloper.com or on Twitter @thesecuredev. Visit heavybit.com to find additional episodes, full transcriptions, and other great podcasts. See you next time.